Okay, let me read through it. It says use a computer algebra system to find the approximate point, that's f of x, with the understanding that f of x is equal to the sine function raised to the x power. It goes on to say where the slope of the tangent at this point is the same as the value of f of x at this point. Restrict your values between 7 and 8. All right, so it's a problem where probably visualizing it first might be appropriate. So what I want to do is I want to go to Sage, and I'm going to start typing things in now. The first thing I'm going to type in is reset. I'm going to define a variable x. I'm going to define a function f of x to be equal to the sine. Whoops. Let's start again. Sine of x raised to the x power. Okay. I'm also going to get another function. I'm going to call it g. And g is going to be the derivative of f, diff of f with respect to x. Whoops, I think I made a mistake. Let's find out where I made a mistake. Differentiate f of x, too many parentheses. There you go. All right, what I'm going to do next is create graph primitives of both sine and the, sine x to the x and its derivative on the interval between 7 and 8. All right, so I'm going to call it fp for f plot, and that's going to be assigned, fp is going to be assigned to the plot. It's a graphic primitive, by the way, of f of x, and x min to be 7, and the x max to be 8. All right, I'm going to do gp, which is going to be a plot of the g thing now. So plot, these are primitives, by the way, we'll show them later. G of x, x min, 7, whoops, and x max to be 8. I want to show that, so I'm going to take fp plus gp, and I want to show it. Okay, I'm seeing it, and right now I'm seeing the two graphs, by the way, and they intersect. It's almost incidental which is which. The point of intersection over here, I'm going to say, roughly speaking, it's about 7.7. All right. Now, when I say it's roughly 7.7, well, it's certainly not 7.8, not 7.6. I'm going to say roughly 7.7. All right. I'm going to say that's my initial guess. I'm going to clear the screen now. Let me get rid of the graph and go back to my terminal. I'm going to clear this screen, and I want to talk about what I need to do now. What I need to do is I need to find a point of intersection. And a point of intersection is where f of x and g of x are going to equal one another. So I'm going to say a new function, because I'm going to use Newton's method now, I'm going to call it h of x is going to be where it's going to be equal to 0, but I'm looking for the roots, is where f of x minus g of x. Again, they're going to intersect, they're going to agree with each other, so that's going to be 0. And I'm going to use Newton's method to refine this. All right? I'm going to define another function called n of x for Newton, and that's going to be equal to x minus h of x divided by the derivative diff of h of x with respect to x. All right, let's see what happens, by the way. I'm going to take n. This is my first guess, by the way, and I thought around 7.7, by the way. All right, let's hit the return. Looks like it's not 7.7, looks like 7.72 now. And what I'm going to do is n again, and I'm going to take the output of that last entry, which that underscore means that's 7.7, blah, blah, blah. I'm going to do it again. I'm going to do it until I see some changes. I'm sorry, until I see no changes. I'm still seeing a change, by the way. I'm seeing a change. I'm not seeing a change there. Let me just do it again. Okay, I'm not seeing a change. All right, so I'm going to say it occurs at about 7.724157.9. What I'd like to do though is I want to understand the point, and the point's going to be, I'm going to evaluate now f of, you know what, I'll assign it to a letter. Let me do this. A. What's A going to be assigned? That number there. So what's A? That number. Let me just do f of A. F of A is that number. All right. Now that's the value of the function there. And it should agree with the slope of the tangent line at that point, which would be g of A. Let's see what happens. Now, granted, I'm not going to say they're going to agree 100%. It's going to have a tough problem, but let's see what happens. It should be a really close approximation, by the way. And what are we getting? Let's take a look at it. Yeah, it's agreeing all the way, almost, well, really to the last digit. It's agreeing. So we have it. Now let me look back over the notes, by the way, and I'll just kind of read through. It says, visualize. We did that. We visualized. Same axis. Starting values where I saw the graphs intersect, by the way. And then I want the stage. What I do with stage, reset, set the variable. I did define a function f. I did define a function g. I did do the plotting, very similar. I did do the h. Let me see if I got that written down for you. Yeah. I did use Newton's method on the h function with the starting position of 7.7. Kept repeating it. Yeah, the same thing. And what's the point of intersection? Well, I'm kind of rounding it off. And I want to point out these numbers are written over here for you. Looks like 7.72. Yeah, I rounded it off correctly, 416. And the y value is this thing over here. Let me just outline that for you. 0.93, 681. I just rounded it. That's all I've done. I've also provided a graph for you. I want to point out what the graph is. The graph is, certainly the derivative being plotted, the function being plotted, and the tangent at the point where those two graphs are intersecting. And that's it. End of story. Thank you for paying attention.